All right, let's go ahead and take a look at number 10. We've got 5/8 a plus 6 equals 3/4 a. Now this is another one of those questions we're going to use that flipping step. If you look at what we have right now, the only thing that's in number 10 that's right is 5/8 a, because that's a variable thing, it's on the left. 6 is wrong, 3/4 a is wrong. But if I flip this around and rewrite this as 3/4 a equals 5/8 a plus 6, now all of a sudden I have two things that are right. 3/4 a is a variable thing, it's on the left side of the equal sign, that's good. 6 is also correct because that's a number thing and it's on the right side of the equal sign. So 5/8 a is the only thing we're going to have to look at fixing here. Now, as far as moving the 5/8 a over, since it's going to go to the opposite side, as you know, we're going to do the opposite, which is going to be to subtract 5/8 a from both sides. Now, some of you are probably already looking ahead here a little bit, and you've already realized what my problem is going to be. On the right side, of course, those 5/8 a's, those are going to cancel each other out. But what I have over here is 3/4 a minus 5/8 a, which is a problem I cannot do as is. Why? When we have fractions involved, you know we have to do common denominators. So we're going to have to go ahead and fix this and do a common denominator. Well, looking at the denominators of 4 and 8, the common denominator is going to be 8. So really all I have to do to make that happen is to double the fraction 3/4, multiply the numerator and denominator by 2. So this is really the same as 6/8 a. And now all of a sudden works. I've got 6/8 a minus 5/8 a, that's 1/8 a. And what does it equal? Well, it equals my other number, 6. All right, multiplication equation at this point, a one-stepper. So we're going to solve this by dividing, but realize what we have here. We have a fraction. We've never divided by a fraction. When we have dividing by a fraction, remember we always solve those by multiplying by the reciprocal, as you saw when we did one-step equations. So to solve here, I'm going to multiply both sides by 8 over 1. And if you want, you can write that as just 8, because 8 over 1 is, of course, 8. On the left side, the 1's and the 8's cancel diagonally and just leave me a. And over here, 6 times 8 is going to change into 48. So a has to equal 48. Let's try number 12, because we're going to run into the same issues on number 12. Now, what I'm not going to have to worry about in number 12, unlike question 10, is the flip. Notice right now that I have two things that are correct about number 12. 1/5 d, well, that's a variable thing on the left, that's proper. And 16 being on the number on the right is proper. Two things right, two things wrong. If I were to try and flip this around, I will still have two things right and two things wrong. So there is no time to be saved in flipping this around. All right, so it doesn't matter what we move first, whether we try and gather the variables on the left or the numbers on the right, that's really irrelevant here. So let's go ahead and take a look at moving the 20 over to this side first. Bring all the numbers to the right. So I'm going to go ahead and knock 20 off both sides. Remember, whenever I want to move something to the opposite side, I'm going to do the opposite. 20 minus 20 is going to make that go to 0. Of course, if I added 20 there, that would give me 20 plus 20, which is 40, which means I hadn't really gotten rid of anything. But 20 minus 20, that's going to go to 0. 16 minus 20 here, that's going to go to -4. And then I've still got all this other stuff in front. The -150 equals 3/10 d. All right, so now we're halfway there, but of course we've got to get the variable things all over to the left, so I've got to look at moving the 3/10 d now. So how am I going to move 3/10 d to the opposite side? Well, again, I'm going to do the opposite, which is in this case subtracting. So I'm subtracting 3/10 d from both sides. Now, as far as this fraction goes, going with this fraction, obviously this isn't going to work, because adding and subtracting fractions requires us to have a common denominator, just like we saw over there in question 10. So I'm going to have to go ahead and fix that, and I'm going to fix that by getting that common denominator, doubling this top fraction, which is going to make this change into a 10 and make the top change into a 2. So this is really -2/10 d minus 3/10 d, which is the same as negative 5/10 d, or if you want, you can simplify it and write it as negative 1/2 d, and it's going to equal negative 4. Again, how did I do that? Negative 2 minus 3 is negative 5, so that would give me negative 5 over 10. Well, 5 over 10 is equivalent to a half, and I kept the negative in there, which is how I got negative 1/2. All right, so it's multiplication right now as it is. Of course, we solve by doing the opposite, which is to divide then. But again, just like in question 10, I'd be dividing by a fraction, which is something we've never done. So we're going to solve this one by multiplying by the reciprocal. So I'm multiplying both sides by negative 2 over 1. And if you aren't seeing that, the 2's and the 1's cancel and leave me d. Here we got negative 4 and negative 2, which is going to make positive 8. So d is going to change into 8.